good mix of different techniques, you're going to tend to find a lot more bugs than if you just bang away with one set. Okay, so as I've said, measuring this stuff by hand, doing these code coverage and psychomatic complexity stuff, not something you're going to want to do for fun, but in some cases there are tools, but as I said, I'm interested in anybody's comments about data flow coverage tools, if anybody's seen one, or if anybody has seen a test catalog coverage tool. I'm not sure that would exist. Fortunately, I think Merrick's technique, like Whitaker's technique, is much more focused on leveraging the skills and experience of the tester. It's not as tedious. It's more of a kind of tips on how to explore the code from a white box perspective. Now, white box testing is good. White box testing is important. I would encourage you all to take it up if it's something that you can apply, or if you can't apply it yourself, to try to make sure that it is being applied by the programmers within the organizations that you're working with. But it's really important to not have a blind faith in white box testing. I think there is sometimes an overconfidence that, so if we test the units really well, then everything's going to be fine. And I think some of that is kind of embedded in some of the things that you hear people say about agile technologies or techniques these days. Oh well, we're going to thoroughly test the units during unit testing, and that reduces the need for subsequent system testing or acceptance testing, or at least it makes it a much lower effort. Now, it should be a lower effort, but I go back in this to Capers-Jones's studies, and he's come up with a figure from his studies across these thousands of organizations and projects that really unit testing is going to top out at about 50% of defect removal effectiveness. So in other words, you're only going to find and remove about half of the bugs. So what can't we find with unit testing? Why would it top out at 50%? Well, part of it is based on the fact that the developers are typically testing their own code, so there's an author bias issue in there. But there are other things that make white box testing not 100% effective against bugs. Of course, nothing is. One thing that you can't find with white box test or what could be called bugs of omission. So missing requirements, design elements, code, that sort of stuff, you can't find that because the code's, you're only going to test what's there. You can only check your coverage of what's there. You can't look for what's not there very effectively with white box testing. So requirements, design, and code reviews are the way to try to find those sort of problems. As I said, it's complementary kind of testing. Unmaintainable code. You could have perfect white box test results and have the code be completely unmaintainable. So, variable names that don't mean anything, so forth. McCabe's psychomatic complexity metric, being a form of static analysis, can help identify unmaintainable code if that has to do with excessive branching. But code reviews and other kinds of static analysis tools are really the way to attack unmaintainable code problems. And then there's a lot of what I refer to as emergent behaviors in systems. So performance issues, security issues, usability, interoperability, and so forth. Those are not really manifested at the unit level where a lot of the white box testing is done. So we need to have code reviews and system testing and beta tests and usability studies and prototypes and all those kind of things to go after those emergent behaviors. So a few conclusions here before we go into the Q&A session. As I said, white box testing is a form of dynamic testing, and it is based on an understanding of how the code works. We have the four main groups of techniques: the control flow coverage, basis paths with McCabe's technique, data flow coverage, and then the test requirements catalog, which is bug coverage, if you will. Tools are very useful if you can get them, and there are many freeware as well as commercial tools available to support this, so I'd encourage you to look for tool supports if you're going to do this. And then, as I've just pointed out here towards the end, whitebox testing is complementary to black box testing and static testing. It's not a substitute. You should employ throughout the organization all three of those types of testing to have a complete testing strategy. Okay, so I will, as usual, put the advertisement up while we go through and then enter our Q&A session here. So at this point, I'm happy to take questions from the audience. See, a number of you have already figured out how to use the tool to submit questions, so let me get those questions out in front of me. This is a new version of GoToWebinar here that they've introduced. It's made this understanding where the questions are a little bit difficult. And let me give me just a moment, if you would, please, and I'll try to get this question panel up. There we go. Good. Okay. Let's see. I had a question from Shmuel at the beginning. Question: will we receive a copy of the slides? As I mentioned at the outset, the slides are posted on the website, so that's rbcs-us.com on the, I believe it's the basic library page, where you can find those slides, and you can download them. That's just the presentation. Now, the recorded version of this webinar will be posted on the digital library page of our website sometime probably in the next few days. So if you'd like to say, tell someone, hey, I heard this presentation on whitebox testing metrics and it really helped clarify a lot of points for me, and suggest that you catch it too, then they can, anybody that you're interested in, you can just forward a link, and they can listen to that at their leisure. And it's basically, it's a WMV that includes all the audio of the presentation and the slides animated as well. Tim, thank you. Tim Riley, my colleague and editor on the book Beautiful Testing that I just contributed to late last year, says the Google search works. Structured testing, this is McCabe's paper. This is on www.mccabe/ looks like IQresearch_NIST.html. Let me see if I can let's see. I'm going to try to get this link up and running, but it looks like if the Google search works fine, you'll be able to find it easily enough. So McCabe structured testing. Let's see, next question here, one from Shmuel. Doesn't covering all the branches automatically cover all the statements too? Yes, Shmuel, good observation. The branch coverage will achieve statement coverage because in order to get to a branch, you would of course have to go through all of the statements, at least through some sequence of statements that preceded the branch. And if there's a non-branching block that precedes the branch itself, as we saw in the Fibonacci program, you'd have to run all of the preceding non-branching statements before you got to the branch. And then once you got to the branch, then there could only be 0 through n number of non-branching statements in each block associated with a branch. In other words, the true and the false side would each have some number of statements there. So the only way that you could get to those statements would be by taking either the true side or the false side of the branch, and that argumentation, if you will, applies pretty much indefinitely as you go through the program. So yes, you will always get 100% statement coverage if you get 100% branch coverage. However, the opposite is not true, and the reason is, this is that point that I stressed earlier. In a switch case construct, there is a default branch even if there is not a defined default block. In other words, there's a possibility of none of the case labels matching the switch variable value, in which case we do nothing. That's the default branch. In an if statement, there's always an else branch, even if there's not a defined else block. So if we say if x